Hello there. We are going to go over how to do Mastering Physics problem number 4 on the energy combo assignment. This one has a ball on a string going through a circular path. I'm going to draw the ball on the string at the two different locations. I highly recommend a picture every problem that you do, where you can label where the object is, maybe how fast it's going, what height it's at. So I'm going to put an arrow here and call this V bottom. I'm going to put an arrow right here and call this V top. When I'm talking about labeling my pictures, what I mean is at the bottom right here, I'm going to call this a height of 0. And the string has a length of L, capital L. So to the center would be a radius of L. But if I'm trying to find the height at the top of a circle is oftentimes found by doing 2 times the radius. And in this case, we're going to write down 2L. Okay, so we have the height at the bottom, the height at the top, speed at the bottom, speed at the top. What this problem is actually asking us to solve for is the difference between the force of tension at the bottom and the force of tension at the top of the path. Because this problem is asking me about forces, I'm going to go right to my toolbox of I should draw a force diagram. Before I even write any equations down, I would like to set them up properly by identifying what forces are happening. And because they're asking about both the top and the bottom, I'll draw a force diagram for each spot. So at the top, we have the ball. I like to draw where the center of the circle is, because when we're in circular motion, we need an unbalanced force pointing towards the center. We would say that the force of gravity is always acting straight down, but that the force of tension is also pulling the ball down. They're working together to make the ball turn. Doesn't really matter which one's bigger right here, because when they work together, we add them to find our net force. When we draw a force diagram, the next step is to write an expression for the net force based on that diagram. So when we look at this diagram here, we're going to see that the net force at the top is going to be equal to the 2 forces added together, because when forces point the same way, we add them up. I now have probably 2 points for my force diagram. I have 1 point for identifying what my net force is. I still don't know an answer, but I'm well on my way to scamming some points and showing I know something. The other place that they asked me for information about was at the bottom of the circle, so I would like to draw a force diagram for the ball at the bottom of the circle. Again, I drew that picture. I'm drawing where the center of the circle is, and I'm going to say that the force of gravity still points down. The force of tension in the direction of the rope has to be bigger than the force of gravity, because I need an unbalanced force pointing towards the center, and gravity's going away from the center. If I'm writing a net force expression for the bottom of the circle, I would say that the net force acting on the ball at the bottom is going to be the force of tension at the bottom minus the force of gravity. The subscripts become important, so I'm going to go back up to the top and write force of tension top, and the bottom's force of tension B for force of tension bottom. Okay, so we've written an expression for each net force based on each force diagram. And whenever we have forces involved, another really good tool for us is to just always say, hey, I could probably use Newton's second law. Net force equals mass times acceleration. That's going to be another point I can get. And when I go in a circle, that acceleration is going to be centripetal. So I know the equation for that is v squared over r. So these are my building blocks for this problem. These are places I can get points even if I can't put it all together. Next, what we would have to do is say things like replace r, the radius of the circle, with L. And maybe even replace FG with MG. Look at that. I just scammed another point, even though I don't know the answer. And now I'm going to try to do some algebra to put it together. So my algebra piece would be to replace net force at the top with mass times acceleration at the top. I'm going to leave force of tension at the top, but I'm going to replace force of gravity with mg. Now, I still don't really want acceleration at the top. What I would rather have is velocity. So I'm going to replace acceleration with v squared over r. I would have my mass times my v at the top squared over r. But remember that r is L, so just place L there. Equals force of tension at the top plus mg. The whole point of doing this is to come up with an expression for the force of tension at the top, right? I need to do force of tension at the bottom minus force of tension at the top. So I would like to just rearrange this and solve this for force of tension at the top. All I have to do is subtract mg from both sides. So, give myself a little room here and say that the force of tension at the top is equal to mv top squared over L minus mg. This is now my expression for the force of tension at the top that I'm going to use later while I'm trying to subtract those two. Next, I need an expression for the force of tension at the bottom, so that I could do that force of tension at the bottom minus that force of tension at the top. I'm going to do a similar process here. Instead of net force at the bottom, I'm going to call that mass times my centripetal acceleration, which is v at the bottom squared over the radius, which is L. So instead of net force at the bottom, I'm doing mv squared over r. Circular motion, you can do mv squared over r. That's m times a. All right, and that's equal to the force of tension at the bottom minus, I'm going to sub in mg again for the force of gravity. And then last but not least, the whole goal is to have this expression for the force of tension B. So I'm just going to isolate it here. The force of tension B can be found by taking mv bottom squared over L plus mg. That's my second expression. So the whole point of this problem, again, is to find the difference between those two. So if I'm going to set that up, I would say something like the force of tension at the bottom minus the force of tension at the top. And that's what I'm trying to come up with an expression for. So I'm going to replace force of tension at the bottom with mv bottom squared over L plus mg. That whole thing right there, again, is my force of tension at the bottom, minus the expression for the force of tension at the top, which is mv top squared over L minus mg. There's my force of tension at the top. We have to be careful with these big expressions when there's a negative sign that we distribute it to each piece. So that leaves us with mv bottom squared over L plus mg minus mv top squared over L plus mg. And so if they let us use v bottom and v top in our answer, then we'd be done. Since they don't, we have to ponder and think, why? Why is this problem in my energy unit? How am I supposed to use energy in order to help me? Well, if I'm talking about energy, I usually like to isolate two different locations and say that the energy at location 1 should be the same as energy at location 2. So we're going to say the energy at the top and the energy at the bottom are the same. When we make these energy bar charts, it helps us set up our equations to say what type of energy is the energy at the top? What type of energy is the energy at the bottom? And so again, going back to that picture labeled with heights and speeds, we would say at the bottom I have a height of 0, so there's no gravitational energy. But at the bottom I'm moving at the speed of v bottom, so I'm going to have a whole lot of kinetic energy there. At the top, I'm still moving. I have this speed v top, but I also have height, remembering that if the radius is length L, that my height at the top is going to be equal to twice my radius, or 2L. So at the top, I have some gravitational energy and some kinetic energy. And so this would be the energy that both the ball and the earth are sharing. To scale an energy point, we could just write something like energy at the top equals energy at the bottom. This would be a good starting point in case we do the next part wrong. You get a point just for identifying that. Another thing you get a point for identifying is just UG equals mg delta y. I need to use this equation. I'm going to write it right off the sheet. K equals 1/2 mv squared. Again, that's an equation necessary for this problem. I have 3 points, even though I might not know how to do this problem. To now get more specific, we would say at the top, there's gravitational energy at the top and kinetic energy at the top. And at the bottom, there's only kinetic energy. To get even more specific, we would replace these with their equations. So this would be mg delta y at the top plus 1/2 mv at the top squared equals 1/2 mv at the bottom squared. Remembering that delta y at the top is twice the length of the string, so mg2l plus 1/2 mv top squared equals 1/2 mv bottom squared. Okay, I now set up all this energy stuff, and I'm wondering how is that going to help me up here? I see that there's like a v bottom and a v top, and I don't know either one of them. And here, in my energy equation, I also have a v bottom and a v top, and I don't know either one of them. So when I have like two equations, two unknowns, I can do some things like maybe substitution. Maybe if I can like solve for one of the v's in terms of the other, it could help me. So I'm going to solve for the v at the bottom in terms of the v at the top. And the reason that I would do that is to say that if I solve for the v at the bottom right here, I could plug that expression in as my v at the bottom up here, and maybe that'll help me like simplify things later. So when I rearrange this equation for energy, I'm just going to isolate v at the bottom. Because my mass is in every single term, it's going to cancel out. And to get v at the bottom by itself, squared, I would just multiply both sides by 2, right? That's like dividing by a half is like multiplying by 2. So really when I'm solving for v at the bottom, I've got 2 times this whole quantity of g2l plus 1/2 v top squared equals v bottom squared. Again, that 2 needs to get distributed. Anything that goes multiplied by both sides has to go to each term. This would really be the same thing as 4gl plus v top squared equals v bottom squared. Now I could go as far as solving for v bottom, but I'm noticing here that in this equation it's v bottom squared, so I might as well just leave it like that, right? Like I could just take what I found as my v bottom squared and put that in up here. So maybe I can copy and paste that. And now I'm just going to plug in m over l times v bottom squared. So that v bottom squared is 4gl plus v top squared. Now that's plus mg, that's the whole pink term, minus Oh, I didn't distribute it. Oh, well. mv tap squared over L minus mg. I didn't pull quite the right one down, but that's okay. You can still distribute this negative sign again. No big deal, right? Here's where the magic happens with algebra. I would like to tell you that for a long time we have not earned any points. And so maybe all of this is not worth it on your test. That what was worth points might have been things like your force diagram and all of the things that have stars next to them. These are all your points. Force diagram. What else? Identifying energy, knowing what type of energy. And all the rest of this algebra that you're going to see me do for a nice long time is worth 1 point. And so maybe that's not your point, and that's okay. But if you'd like to see it, here it is. This m over L goes to this term and that term. So I'm going to have m over L times 4GL plus m over L times V tap squared plus mg minus mv tap squared over L plus mg. That was fun. Let's look at the first term. Watch how those L's canceled out. That first term's really just 4mg. Let's check this out. M over L V tap squared minus m over L V tap squared. Ta-da! There it goes. So I had 4mg plus mg plus mg equals 6mg. That was a lot of algebra for just 1 more point. Decide if you think it's worth it. Should you spend your time there, or should you just move on to another problem and come back? Choice is yours. Have a great day.